Usman Ilyas. Thank you for the lovely introduction. I'm an assistant professor of computer science at the University of Jeddah, and my talk today is going to be about some of the next challenges that we face in artificial intelligence. There are actually many different challenges. When I was starting to make this talk, a couple of things sprang to mind, but then I was reminded that I only have 15 minutes, so I had to keep it short. So among the things, next big things in AI are artificial general intelligence, or what Ray Kurzweil called the singularity. Basically, an AI that equals and ultimately overtakes human intelligence. And I will spare you the otherwise obligatory reference to the Terminator and Skynet. I won't do that, but I will show you this guy. Another big challenge, learning with small data sets, and that's actually quite hot these days. Right now we're kind of into the easy first 10% of artificial intelligence. We've solved the easy problems in AI, the ones for which we have the data sets, the resources available. But the remaining 90% is still up for grabs. And one of the next problems in AI is basically how do you teach an AI system, how do you train an AI system without having millions or billions of training data points available to you? And if you think that's not possible, if that's something sci-fi, like the first topic that I thought about, it's not necessarily true. Think about how a child learns. How many instances, how many examples do you have to show a child for it to learn something new? Let's continue with this example. Let's consider object recognition, for example. Parents show their kids sometimes pretty abstract drawings of objects, like this dog over here, for example, and the kid sees it again and again in some children's book, and it's told dog, dog, again and again. A couple of examples, a handful of examples maybe, and soon enough, the kid is able to recognize not just this one dog, not just this one exact dog, but a whole wide variety of dogs from that one two-dimensional training image. Now, that's something for us to shoot for in AI. So, third thing I thought about was ethical AI systems. And actually, that's the one I landed on. I found that that's perhaps the one that is also most relevant to all the contestants in this startup weekend. So let me explain what I mean by that. So obviously there are many different ethical issues when it comes to AI systems, but I wanted to specifically talk about something called bias. So bias, dictionary definition of it is inclination or prejudice for or against a person or group in a way that is considered unfair. Now, in AI systems, that can occur on the basis of, say, age, or maybe the data set that you have contains gender information, or maybe it contains information as to the race of a particular person, or nationality, or income level. We have names for all of these: ageism, gender discrimination, racism, classism, elitism, when it comes to income level, and residence, like which part of the city, for example, you live in. Now, this may seem a little abstract, perhaps, but let me give you an example, a very simple example that will show you how. You may think, you know what? Maybe we can design our systems so that they're not biased towards or against a certain person. Now, let me show you a straightforward example first. Let's say we have a system that accepts, approves, or rejects people for a certain benefit, some social benefit. Maybe it's a loan, maybe it's something else. And let's say we have a data set that we're using to train our system to do that for us, to do it well. So let's consider one of the features that we have available to us in that data set. Let's say age. And let's say we have some people on this number line of age that will be accepted. Their ages fall somewhere over there. And then we have some other people who will get rejected that happen to fall on that side of the line. You can see pretty clearly that this something is not right. The classifier that is doing that is actually quite straightforward. Basically, you have a cut-off age. If someone is older than a certain age, that person is basically on this one feature alone disapproved or rejected from getting that benefit. Okay, so you may say that, you know what, this is pretty straightforward. I can do that. If I have a data set, I'll open it up and I'll go feature by feature and I'll look for such bias. No problem. Bias problem solved. The problem is actually not that straightforward. It's not always that easy to spot. Let's take another example. Let's say this data set over here. We have people with these different ages. Some have been accepted for their benefits, some have been rejected. Now, would you say that this classifier, however it is working, is fair? Is it? I usually teach, so I'm usually used to getting feedback from people.
The voice.
So it looks like, you know what, the approved and the rejections are pretty evenly distributed on the age line. So it seems like it probably looks like a fair system. Let me do something. We usually use many different features when it comes to designing AI systems. So let me throw in a second feature. Let me throw in income level, for example.
Hi there, voice please. The voice you can.
All right, so better. So let me throw in income level as a secondary feature. Now, if I have two features, it means these points have to be drawn on a two-dimensional plane. So let me move them into 2 dimensions. All right. And now, I want to classify between them. And this line is the classifier. Does this look fair to you? What does this classifier do? What is the system doing? It is discriminating against poor people with low income, even if they're young. They have a high income, they get through, they get accepted. And even if somebody has a high income, like someone towards the right end, they can still get rejected if they are above a certain age. So, while initially it may have seemed that was a fair classifier, if you look at it in an additional dimension, that same system might in fact still be unfair. And what we just did, going from 1 dimension to 2 dimensions, the same thing can apply to a classifier. Let's say we look at it in 2 dimensions, it may look fair. Look at it in a 3rd dimension and the unfairness can become clear and apparent. Okay. So, and as the number of features that you look at together at one time, as that increases, this problem becomes non-trivial. It's not necessarily an easy problem to detect. Why should you care? Why am I telling you this? The reason I'm telling you about this is this. The GDPR, the General Data Protection Regulation, was designed in 2016, came in effect May of 2018, this year. And it applies to all EU countries and all countries in the European Economic Area. So, what's it say? Basically, what does it do? What does this law do? This law basically prevents anyone from discriminating against individuals in the EU or European Economic Area. Now, notice that I did not say citizen. If you're living in the EU as a student, as a foreign student, as an exchange student, you still get the protections of this law. Okay? So why should you care? Well, you're all here for an AI edition of startup weekend, which means you will be coming up with hopefully very exciting applications of AI systems. And ultimately, you're not building these just to satisfy your intellectual curiosity. You hope to come up with a viable business, make money, sell this to someone, right? Now, again, why should you care? The reason you should care is that if you want to sell in the EU market, you have to comply with its regulation. And you may say, you know what, it's too hard to comply with. We'll just skip the EU as a market. Consider this. Global GDP, $127 trillion for last year. Out of that, the EU has the second biggest slice of that pie, 19.9 trillion US dollars. Now you may say, you know what, I can just go to the US. Yes, you can. I may just sell in China. Sure, you can. And after that, you'll be foregoing 1/6 of the global market. This big orange pie that you're seeing, this orange piece, 49.7 billion, that's the entire rest of the world. When you go into a country to sell, you have to comply by their laws. That orange piece that you see, that is about 190 different countries with 190 different laws. What do you think is easier? Going into one market and figuring out how to comply with those laws, or trying to comply with 190 different laws? So this is not something you can ignore. Actually, it's true to the extent that now even companies operating out of the US but serving people in the EU have to comply by this law. So if you ever wish to sell into the EU, you've got to know about this. And what are the most important parts of this? I'm not a lawyer, okay? Not by a long shot. I just want you to see two lines. Pay attention to those. So first of all, this is Article 22, paragraph 1. Just don't read everything. Just read the underlined portion. Pay attention to the red part. Subject shall have the right not to be subject to a decision based solely on automated processing. That's you guys, including profiling. That's all of that personal information that we saw in the beginning. Age, gender, all of that stuff. Yes? I'm sorry, I can't hear you.
Was this law made after the Eastern European countries joined in, so to avoid discrimination from the poor Eastern European countries?
Like I said, I'm not a lawyer. I can't tell you.
I mean,
how this law was made.
The
but I
history
know
of this GPR, when it's approved.
Approved in 2016. That's when the law was made, and it's been applicable since May of this year, May 2018. So yes, like I said, if you want to sell in the EU, you comply by it. This is bad enough in a sense, but then there's another. Just one more that I want to show you. So controller of that system shall provide data subject with the following information. Meaningful information about the logic involved in whatever decision your system came to. Okay? Why is that something for you to think about? Meaningful information about the logic involved. This is a whole different challenge. This is actually a new research. This is a very recent research area in AI. You have to be able to explain from one instance, one input that you're giving to your system, how your system generated that certain output, how it came up with that prediction, that recommendation, how you got to it. Explain it in English, okay, not the math. This new field, this new area of research in artificial intelligence is called explainable AI, or explainable artificial intelligence. The ability to explain how a certain decision was arrived at. Now, many different methods, many different techniques that we use in AI. I'll just go through just a few, and some of them are fine If you look at them from perspective of explainability, as rule-based AI systems have been around since forever. Okay, no problem explaining how you get to a certain recommendation in a rule-based system, something made in Prolog. It's very straightforward to go through the reasoning and figure out, so this is how we got to a certain output, no problem. Then we have regression-based systems. Again, older than time, okay? They've been in use in many different sectors. They're frequently used for risk, credit prediction, risk prediction, in finance. They also happen to be very well regulated. And on top of that, from a technical perspective, it is kind of straightforward to determine which input factors factored in the most in the output decision. And we have decision tree-based systems. Again, slightly more recent, but very similar to rule-based AI systems. It is very easy to figure out, okay, this is how we got to that certain decision. And again, rule-based decision tree-based systems frequently used in the same areas as rule-based AI systems. But many of the hot new applications of AI that you guys know of, self-driving cars and self-organizing drones, they usually don't use any of those. The reason we have this explosion of interest in artificial intelligence these days is because of advances in a whole different area of AI, and that is deep neural networks. Now again, neural networks have been around for a while, but the ability to train primarily these very deep, very large neural networks, that is more recent with advancements in computer architectures and GPUs. And here's the problem. Up till now, in general, it is not possible to explain why or how the output of a deep neural network is what it is. How different inputs factored into the output decision. So all of that, the most interesting technology in AI, the most interesting technology of the day is the one that might get you into legal trouble in the EU. So explainability. So from another perspective, you can think of neural networks as a black box. And if you think that is not problematic, you can somehow get around that, or maybe you really won't sell in the EU. Consider this. Consider for using an AI system to determine what interest rate it is going to offer its customers on their mortgages. And it just so happened that African American applicants, Hispanic applicants were getting a higher interest rate. Demographic information, misuse of demographic information. Okay, the result is this. And what do you think? Did JP Morgan build that system itself? No. It hired someone like you, a company like you guys. Okay, and you guys, someone like you was responsible for that. So yeah, in this case, JP Morgan got sued. Might as well be a smaller company like you guys. Just one more example. This is also from the US, by the way. Okay, no GDPR in effect over there. Courts are using a system over there called Compass. What they do with that system is, when they arrest someone, they take the information that that person gives, they feed that into Compass. Based on that, the system gives them a risk assessment of how likely this person is to commit a crime again. And as it turns out, again, the system is oftentimes biased towards minorities. That system, the system Compass, has also been developed, has not been developed by the Department of Justice, has been bought by a vendor, from a vendor, and again, the case went to court, and they were not able to open up and explain how the system came to the decisions that it did. So, I'm being told that I'm almost out of time. So the quick takeaways for this weekend, for this startup weekend, for you guys. target market and know what types of, what laws you have to abide by, what the rules of the game for you are. Be mindful of bias for or against individuals or groups, for or against individuals or groups in your system, if you can. I know this is just 2 days of development, probably won't get to it, but this is something to keep in mind. If your chosen AI technology allows for it, see if you can explain the outputs from your system. And that's it. Good luck to all. Thank you very much.